Hello and thank you for joining us. In this video we're going to look at polynomial long division to find quotients and remainders when a polynomial is divided by another polynomial. Right? In this examples we're going to have a quadratic divided by a linear and a cubic polynomial divided by a linear polynomial. So recall that a polynomial is simply a function that can be written in this form where we have a sub n x to the n plus a sub n minus 1 x to the n minus 1 all the way down to a sub 1 x plus a sub 0, where these n's are non-negative integers, right? So we could say that those exponents are not negative and not fractions, right? So we can say they're natural numbers. Okay. At times, it will be useful to write a polynomial in a different form, right? This p of x equals d of x times q of x plus r of x, where d of x represents a divisor, q of x represents a quotient, and r of x represents a remainder. So for example, the polynomial p of x equals x squared minus 3x plus 1 can be written as p of x equals x plus 2 times x minus 5 plus 11, where x plus 2 represents a divisor, x minus 5 represents a quotient, and 11 represents a remainder. All right? So let's look at that polynomial. P of x is x squared minus 3x plus 1. Let's use polynomial long division to find the quotient and remainder when p of x is divided by x plus 2. And hence, we're going to rewrite p of x in the form p of x equals x plus 2 times a quotient plus a remainder. All right, so for our polynomial. So doing our long division, we have our divisor, right? What we're going to divide by is x plus 2. We have our dividend, what's being divided, as x squared minus 3x plus 1. And we're going to do our long division as we normally would. It is important that in this polynomial long division, we have a column for our constant, we have a column for our linear terms, we have a column for our quadratic terms, our x squared terms. Okay, so we look at our x and we say, hey, x times what will get me x squared? And I should recognize that x times x should get me x squared. So x times x is going to be x squared. X times 2 is going to be 2x, and that's going to be a positive 2x. And then our division algorithm, we can say, okay, now we're going to be subtracting. So x squared minus x squared is 0. Negative 3x minus positive 2x is going to be negative 5x. Right, and let's bring down that positive 1. So our next step is to say x times what is negative 5? Well, that's going to be x times negative 5. Negative 5 times x is negative 5x. Negative 5 times 2 is negative 10. And then I will subtract there. And negative 5x minus negative 5x is going to be 0. 1 minus negative 10, that's going to be 11. And so I can identify, right, that this part up here, this is going to be my quotient, right, and this part down here, that's going to be my remainder, okay? Now we're also asked to rewrite this p of x in this form, x plus 2 times something, and so we can say, hey, p of x is going to be that x plus 2 times x minus 5 plus a remainder of 11. Right, so we see kind of what we had in our example above. If we wanted to check to see if we had the information correct, we could certainly distribute and verify. Right, so we have x times x, that's going to be x squared. X times negative 5, that's negative 5x. 2 times x, that's plus 2x. 2 times negative 5, that's negative 10, and then I have plus 11. So I could see that p of x, if I expand this, is x squared minus 3x plus 1, which is what I expected it to be. So this long division, I set up in the regular form of my division algorithm. I have my divisor on the outside. I end up with my quotient at the top, and I end up with the remainder down here at the bottom. Be organized in your work. This skill to determine the quotient will be used later when we discuss rational functions and when we discuss slant asymptotes. So important skill to recall for the future. Now, let's say that we had this next question that says, hey, find the quotient and the remainder when 4x cubed minus 3x plus 5 is divided by 2x minus 3. So let's set up with our divisor outside here, so 2x minus 3. All right, we have our dividend, we have 4x cubed, and then I'm going to make sure I put a 0x squared to hold this x squared column. Then I have minus 3x and plus 5. All right, once again, the reason for that is, let's say that you were dividing 1032. You're saying, hey, what's 1032 divided by 5? All right, well, you have the 2 in the ones column, the 3 in the tens column, the 0 in the hundreds column, and the 1 in the thousands column. This is effectively the same thing. I have a 5 in the constant column, negative 3x in the linear column, a 0x squared in the quadratic or the x squared column, and a 4x cubed in the cubic or the x cubed column. So 2x times what gets me 4x cubed? That's going to be 2x times 2x. So 2x times 2x, that's 4x cubed. 2x times negative 3, that's negative 6x squared. Let me go ahead and subtract. And if I do that subtraction, that should give me a positive 6x squared there, because 0 minus negative 6x squared. All right, let's go ahead and bring down that negative 3x. That'll come down. And I'll say, well, 2x times what is 6x squared? That's going to be plus 3x. Oops, I forgot the x squared there. All right. So I have 2x times 3x gets me 6x squared, and so there's the 6x squared. 3x times negative 3 is negative 9x, and if I subtract at this level, 6x squared minus 6x squared is 0. Negative 3x minus negative 9x, that's going to be a positive 6x. Let's go ahead and bring down the 5 from our division algorithm. And now I say 2x times what is equal to 6x? That's going to be 3. And so I have then 3 times 2x minus 3. That's going to be 3 times 2x is 6x. 3 times negative 3 is negative 9. And I am subtracting here. All right, and so this gives me 0, and here gives me 14. So what does that tell me? That tells me that my quotient is 2x squared plus 3x plus 3, and that my remainder is 14. Right? This quotient, like we said, we'll use later on when dealing with rational functions and slant asymptotes, and this remainder is useful to know. Same thing for graphing later on. It relates to some details. At this moment, we won't want to go into those details. All right, but of course, if I wanted to rewrite this expression, I could rewrite that expression as 2x minus 3 times 2x squared plus 3x plus 3, and then with the remainder of 14. And if I was to distribute all of this, I should end up with 4x cubed minus 3x plus 5. So that's polynomial long division. Be sure to keep to organize your long division appropriately. That includes having the 0 in the column related to the location where you're missing a term. Okay? Thank you for your time.